Hello there, Des Lynam here, and I'm introducing this video as a keen but very amateur golfer. Like most other amateurs, I've seen all the videos, read most of the books, and had a few lessons. Certainly enough to recognize that what you're about to see represents a very different way of looking at the game of golf. What it says is, there's no real mystery. If it's too complicated, simplify it. If it's happening too fast, slow it down. An approach that says, just the facts, please, and facts that can be proven. I'm under strict instructions not to say the word science in case I put anyone off. If, like me, you feel your golf has reached a sort of plateau, maybe a new perspective on the game is just what you need to get your game back in shape. This film's certainly given me a clearer picture of how golf works, and I hope you find it as useful and as informative as I have.
Rolling? Yeah. Good. Just don't want you to miss this beautiful drive.
The full golf shot happens fast. A good golfer accelerates the club from 0 at the top of the backswing to over 100 miles an hour at impact in about 1/5 of a second. The moment of impact lasts less than 1/1000th of a second. Because it all happens so fast, it's hard to see how it works with the naked eye. But just because it's hard to see, it doesn't follow that it's impossible to understand. This video is about the basic truth of how golf shots work, the facts of golf. Like the facts of life, they're useful to know and best explained early on. Often they're not, and for many of the same reasons. Golfers love to use photographs to help analyze the swing, often unaware that some cameras are capable of giving a completely false record of things that are moving at speed. This photograph, apparently showing an impressive bend in the shaft as the club nears the ball, does not represent a single moment in time. The camera which took it has a focal plane shutter. The film is exposed through a moving slot in order to get even exposure. Fine for this sort of picture. But when objects moving through the frame approach the speed of the moving slot, strange distortions occur. Photographs like this have been more hindrance than help. They have led many people to believe that the wrists are providing a great deal of the shot's power, and nothing could be further from the truth. In reality, clubs bend to only a small degree as they approach the ball, and when they do, the bend is as a result of centrifugal force acting along the length of the club, causing the head to bend towards the ball. So before using any kind of camera to analyze golf, it's important to understand exactly what it's showing you. An ordinary TV camera takes in enough information to make a recognizable picture every 50th of a second. But like the focal plane shutter camera, it doesn't take all the picture at the same instant in time, and it's also confined to one exposure length. So these pictures also misrepresent very fast-moving objects, as well as making them quite blurred. New TV camera techniques, however, make it possible to record each picture through an electronic shutter, making a variety of exposure lengths available. These cameras can grab an image in less than 1/1000th of a second, then display it for the normal 50th of a second. This is the Murphy's Cup, one of the first competitions to be televised using this new type of camera. Pictures like these can be used to calculate ball and club head speeds and provide a series of high-quality freeze frames which allow a very detailed look at any swing. Adding the frames together gives what could be described as a swing pattern. Domestic versions of these cameras are available, and one of the most constructive things any golfer can do is to arrange to see their own swing on video. Often they find there is a world of difference between what they think is happening as they swing and the truth. But that's as far as a TV camera can go. A stage ahead, a special film camera. This one is capable of taking up to 500 frames in a second. And when the results are played back at the normal rate of 25 frames a second, a telling slow motion emerges. Yet even taking a single picture every 500th of a second is not enough to capture some of the more elusive events that go to make up the golf shot. In order to study the effects of club and ball contact, we return to still photography, exposing the film with precisely timed short-duration flashes which capture moments best measured in microseconds. Using all these camera techniques, it's possible to build up an accurate picture of the way the mechanics of golf really work.